Welcome to the AI Show by Brainwave Audio. I'm Jack Rivers, and with me is Emily Harper, our AI expert.
Hi, everyone.
Each week, we bring you the most exciting developments in artificial intelligence and machine learning, breaking down these complex topics and showing you just how AI is shaping our world.
That's right.
And today, we're diving deep into something really fascinating, a brand new development from Microsoft Research.
BiomedParse.
BiomedParse.
Yeah, it was just published today, November 18th, 2024, and it's already making waves.
Wow, so fresh off the press.
Yeah, and what makes BiomedParse so fascinating is its potential to revolutionize how we analyze medical images, particularly for complex diseases like cancer. Imagine if you could glean insights from these images faster and with a more integrated approach than ever before.
Okay, that's a big claim.
It is.
So why don't you walk us through what makes BiomedParse so groundbreaking?
Sure.
I understand it has something to do with limitations in current tools like MedSam and SAM,
You got it.
which focus solely on image segmentation.
Right. Tools like MedSam and SAM are great at outlining specific objects in an image,
Okay?
but they miss the bigger picture.
The bigger picture.
Think of a radiologist or a pathologist analyzing a medical image, like a CT scan or a pathology slide.
Right.
They're not just looking to identify a tumor. They're trying to understand its boundaries, how it interacts with surrounding cells, and so much more.
So much more.
This requires a holistic view.
Holistic view.
That goes beyond simple segmentation.
Okay, so how does BiomedParse address this need for a more holistic approach?
Well, BiomedParse brings together three crucial steps:
Okay.
object recognition detection and segmentation,
Gotcha.
into a single unified framework.
Yep.
Traditionally, these have been handled separately,
Separately.
which can be time-consuming and limits the insights that you can gain.
Okay, so instead of having to use multiple tools and manually analyze different aspects of the image, BiomedParse offers an all-in-one solution.
Exactly. And it does so with remarkable user-friendliness.
User-friendliness.
Imagine, instead of meticulously drawing boxes around every single cell in a complex image, you simply type a natural language description what you're looking for.
Wow.
You could say, show me all the tumor cells interacting with lymphocytes.
Okay.
And BiomedParse would not only label those cells, but also precisely outline their shapes on the image.
That's incredible. It sounds like having a superpowered assistant that understands exactly what you need and instantly delivers the results.
Exactly.
But how does it actually work? What's the magic behind BiomedParse?
Well, the real magic lies in how they trained this model.
Okay.
They used GPT-4, the powerful language model, to create a massive data set called BiomedParse data.
Wait, GPT-4 for analyzing images.
That's where it gets really interesting.
I am thinking that how did they use a language model to train a system for analyzing images?
Well, they cleverly leveraged GPT-4's language capabilities to organize and harmonize existing biomedical image data sets, which often have unstructured and messy text descriptions. Think of it as using GPT-4 to clean up and categorize the data, making it usable for training BiomedParse.
So they used GPT-4 to make sense of the massive amounts of data needed to train BiomedParse. That's pretty ingenious. But how much data are we talking about here?
BiomedParse data is enormous.
Okay.
We're talking over 6 million image sets encompassing 64 major object types, 82 subtypes, and images from 9 different modalities.
9 different modalities.
This means BiomedParse can work with various types of medical images, not just one specific kind.
Okay, so we've got a lot of data, 9 different modalities.
Yeah.
But with all this data and sophisticated technology, the big question is, does it actually work? How does BiomedParse perform compared to existing methods like MedSam and SAM?
That's the exciting part. They evaluated BiomedParse on a large test set and found that it significantly outperformed existing methods.
Wow.
Even when those tools were given an advantage, being told exactly where to look in the image with a bounding box.
Wow, that's a bold claim. Yeah. How do they even measure performance in something like image analysis?
Well, they use a metric called the DICE score.
DICE score.
Which basically measures how well the AI's prediction matches the actual image. Think of it as a percentage of overlap. The higher the score, the better.
Gotcha.
BiomedParse scored between 75 and 85 points higher than MedSam and SAM on this metric.
Wow. That's a significant improvement.
It is.
Clearly, BiomedParse is a major leap forward in accuracy.
Absolutely.
What other advantages does it offer?
One key advantage is efficiency.
Okay.
By eliminating the need for manual bounding boxes, BiomedParse significantly reduces the amount of user effort required.
Yeah.
Imagine the time saved for clinicians who analyze hundreds of images daily.
Right.
This could be a real game changer in a field where time is of the essence.
Absolutely.
Plus, the paper mentions that BiomedParse excels at recognizing and segmenting objects with complex, irregular shapes, which are particularly challenging for traditional methods.
That makes sense.
Yeah.
Its ability to learn more complex shapes makes it ideal for understanding complex diseases like cancer.
Exactly.
Where the shape and interaction of cells can be crucial for diagnosis and treatment.
Right, and it does so with significantly less user effort than previous methods.
Less effort.
Imagine having to manually draw a box around every single cell in a complex image versus simply typing a description of what you're looking for.
That's a world of difference.
Yeah.
Okay, so we've got a powerful model trained on a massive data set, and it seems to be blowing existing methods out of the water in terms of both accuracy and efficiency.
You got it.
But what does this all mean for the real world? Where could this technology make a real impact?
Well, the potential applications of BiomedParse are vast and incredibly exciting.
Okay.
This technology could revolutionize precision health, leading to earlier disease detection, more accurate prognosis,
Gotcha.
better treatment decision support, and more effective monitoring of disease progression. Just imagine personalized medicine tailored to individual patient image analysis.
That sounds like something out of science fiction. It's like having a personalized medical expert for every patient.
Yes.
Helping doctors make faster, more informed decisions based on precise image analysis.
Precisely. And the best part is BiomedParse is open source.
Open source.
And available on Azure AI for real-time inference. There's even a demo for anyone to explore.
Wait, so anyone can actually try out this technology?
Yeah.
That's incredible.
It is.
Microsoft has made it widely accessible, which could lead to even faster progress in this field.
Absolutely.
This is truly exciting news. BiomedParse seems to be pushing the boundaries of what's possible with AI in healthcare. It looks like we're on the cusp of a significant transformation in healthcare, with AI playing an increasingly prominent role. But before we get ahead of ourselves, let's take a moment to recap what we've learned so far about BiomedParse.
Okay.
And then delve a bit deeper into some of its more nuanced aspects.
Let's do it.
Right.
So we've talked about how groundbreaking BiomedParse is in terms of accuracy and efficiency. But what's equally fascinating is how they achieved this level of performance.
You're right. We kind of glossed over that. I'm still trying to wrap my head around using a language model to organize image data.
Yeah.
Can you walk us through that a little bit more?
Absolutely. Existing biomedical image datasets often come with unstructured text descriptions. Think of free-form notes by researchers or clinicians.
Right.
This makes it really difficult to use this data for training AI models, which need structured and consistent labeling. That's where GPT-4 comes in.
Okay.
The researchers used its language capabilities to essentially clean up and categorize this messy data.
Clean up the data.
Creating a unified and consistent taxonomy for all the different object types in the images.
So GPT-4 acted like a superpowered librarian, taking all these scattered notes and organizing them into a neatly categorized system that BiomedParse could understand.
It's a great analogy, and they didn't stop there. They also used GPT-4 to synthesize additional object descriptions, further enriching the data set and ensuring that BiomedParse had a wide range of examples to learn from.
Wow.
This innovative use of GPT-4 is a significant part of why BiomedParse is so successful.
That's incredible. It really highlights the versatility of these large language models and how they can be applied in unexpected ways. Makes you wonder what other creative uses we'll find for them in the future.
Absolutely. This research definitely opens up exciting possibilities for the future of AI development, especially in fields like healthcare, where the data can be so complex and varied.
Speaking of healthcare, let's shift gears a bit and talk about the real-world implications of BiomedParse. You mentioned earlier that it could revolutionize precision health.
Yeah.
What exactly does that mean for patients and doctors?
Well, imagine a world where disease detection happens earlier, diagnoses are more accurate, and treatment plans are tailored to each individual patient based on a precise analysis of their medical images.
Yeah.
That's the promise of precision health.
Precision health.
And BiomedParse could be a key enabler of this vision.
Can you give us some concrete examples of how BiomedParse could change things?
Certainly. Let's take cancer detection as an example. Early detection is crucial for successful treatment.
Absolutely.
BiomedParse's ability to analyze images with such high accuracy and efficiency could help doctors spot subtle signs of cancer that might be missed by the human eye, leading to earlier interventions and potentially saving lives.
Potentially saving lives. That's powerful.
It is.
And what about personalized treatment plans? How could BiomedParse contribute to that?
Think of a doctor trying to decide on the best course of treatment for a cancer patient.
Okay.
With BiomedParse, they could get a much deeper understanding of the tumor's characteristics, its size, its shape, how it's interacting with surrounding tissues.
Yeah.
This granular level of detail
Oh.
could help them select the most effective treatment plan, minimizing side effects and maximizing the chances of success.
So BiomedParse could act like a powerful decision support tool, helping doctors make more informed and personalized treatment decisions.
Exactly. And it's not just limited to cancer. BiomedParse's versatility means it can be applied to a wide range of diseases and medical conditions, potentially revolutionizing how we approach diagnosis, treatment, and even drug discovery.
It's amazing to think about the possibilities. This technology has the potential to truly transform healthcare as we know it.
It certainly does. And the fact that it's open source makes its impact even more significant.
Open source.
Researchers and developers around the world can build upon this work, accelerating progress in the field and potentially leading to even more groundbreaking innovations.
Wow, so it's like a domino effect of innovation, all sparked by this initial breakthrough.
Exactly.
That's a great point. Open source initiatives like this can be incredibly powerful drivers of progress, especially in fields like healthcare, where collaboration and knowledge sharing are so important.
Absolutely. And with the ability to access BiomedParse on Azure AI for real-time inference, the barrier to entry for researchers and developers is even lower. It's truly democratizing access to this powerful technology, allowing anyone with an internet connection to explore its potential.
And let's not forget the demo. I'm sure many of our listeners are eager to get their hands on this technology and see it in action for themselves.
Yeah.
It's not every day that you get to interact with cutting-edge AI like this.
You're absolutely right. The demo is a fantastic way for people to get a first-hand understanding of what BiomedParse can do. It demystifies the technology and shows its real-world applicability in a way that's accessible and engaging.
It sounds like BiomedParse is a remarkable combination of groundbreaking technology, innovative data utilization, and a commitment to accessibility. It's a perfect example of how AI can be harnessed to address real-world problems and potentially improve the lives of millions. What are your final thoughts on BiomedParse?
I'm incredibly excited about the potential of this technology. We've seen how it pushes the boundaries of what's possible with AI in healthcare, offering a more accurate, efficient, and user-friendly approach to medical image analysis. But what truly stands out to me is the commitment to open access and collaboration.
Open access.
By making BiomedParse readily available to the wider research and development community, Microsoft has opened the door for a wave of innovation that could transform the future of healthcare.
I couldn't agree more. BiomedParse is a shining example of how AI can be a force for good in the world.
It really is.
Now, before we wrap up this episode, let's give our listeners a quick recap of the key takeaways and where they can learn more. Okay, so let's recap what we've learned today. BiomedParse is a real game changer in medical image analysis. It's like having a super-powered assistant for radiologists and pathologists, helping them make faster and more informed decisions.
Absolutely. By unifying object recognition, detection, and segmentation into a single framework, BiomedParse really streamlines that whole process and offers a level of accuracy and efficiency that really surpasses existing methods. It's really incredible. And what's so exciting is how they're using cutting-edge AI like GPT-4 to make this happen. Who would have thought a language model could be so useful for analyzing images? It speaks to the versatility of these large language models.
It's remarkable. And they didn't just stop at using GPT-4 for organizing the data. They also used it to synthesize additional object descriptions.
Oh, wow.
Creating this incredibly rich and diverse data set for BiomedParse to learn from.
Yeah, this innovative approach is a big part of why BiomedParse is so effective.
Absolutely.
And we can't forget about the potential implications for precision health. Earlier disease detection, more accurate diagnoses, personalized treatment plans tailored to each individual patient.
The possibilities are truly vast. BiomedParse could revolutionize how we approach healthcare, leading to better outcomes for patients.
Absolutely.
And a more efficient and effective healthcare system overall. It's really inspiring to see how AI is being used to address these real-world problems and make a positive impact on people's lives. Now, for our listeners who want to dive deeper into BiomedParse, where can they go to learn more?
Well, the great thing is that Microsoft made BiomedParse open source. So anyone can access the code and kind of explore its inner workings. They've also made it available on Azure AI for real-time inference. And there's also a demo.
A demo?
That allows you to experience its capabilities firsthand.
That's fantastic. We'll be sure to include links to all of those resources in the show notes. And for those who are interested in the nitty-gritty details, we'll also link to the original research paper published by Microsoft Research.
I highly encourage everyone to check it out. It's a fascinating read, and it really showcases the incredible work being done at the intersection of AI and healthcare.
Well, Emily, this has been an incredible deep dive into BiomedParse. Thank you so much for sharing your expertise with us today.
It was my pleasure. I'm always excited to talk about the latest breakthroughs in AI, especially when they have the potential to make such a positive impact on the world.
And to our listeners, thank you for joining us on the AI Show by Brainwave Audio. We hope you found this episode insightful and engaging. Be sure to tune in next week for another deep dive into the world of artificial intelligence. Until then, keep those neural networks firing.